Enjoying the conference? Yay! So the first thing we gotta do is to take a selfie, for sure. Because rarely we can be on the main stage. Okay. So let's try to do it. So everybody says spring. Spring. Great. I like your enthusiasm. Okay, let's get it started.
So just before we get started, if anyone has any questions, you can put them in the app, and we'll try to check that by the end of the talk and make sure that we answer any of your questions.
If we don't forget.
If we don't forget, which is very likely to happen, please remind us. But also, we're going to be showing a lot of UI elements where we might need to zoom in so that you can see it. So if you're sitting in the back and you don't have amazing eyesight, you may want to move a little bit farther forward, but wherever you're comfortable.
Okay, so welcome everybody to our presentation titled Observability of Your Application. So my name is Marcin Grzejszczak. I know, like the last name is a mess. So this is why I picked as my Twitter handle the first letter of my first name and the whole surname. So that was a good idea. But if you go to my blog, toomuchcoding.com, you can find a link to my Twitter handle. And then I created an account in Mastodon, which was the same. I made the same mistake. I created it like with my last name, but I renamed it to Too Much Coding, which is much better.
And I am Ludwig. I am super excited to be here in Barcelona with all of you today. I came on a 20-hour flight from Japan, and I am still jet lagged, so bear with me if I'm not making any sense. But this is one of the greatest spring conferences, and if you're watching this recording and you haven't come to this, you really should. And I'm really happy that you all are here, and we're really excited to talk about observability in your application. So this is our lawyers make us do this. Don't sue us. Don't take anything that we say for absolute truth. And before we get started with the actual talk, I want to gauge the audience a little bit.
Gauge, like the micrometer gauge. It's a joke, like gauge.
That's all right. That's all right. We laugh for our own jokes. It's fine. It's fine. So, how many people in the audience, by show of hands, are already using Spring Boot 3?
Wow.
Oh, that's about half of the audience, I'd say. It's pretty good, pretty good. And how many people are using observability in production, where we don't really define what observability is, whatever it means to you? Who's doing observability in production?
Yeah, quite a few.
About half, again. All right, not bad, not bad. And how many of you are using Micrometer already? Pretty good, okay.
Who of you is actually reacting to alerts? Okay, some people, good. Okay, not ignoring them, that's good.
All right, so we just wanted to kind of see where everyone was at in the audience. We're going to try to do this so that it hopefully makes some sense and you can get something out of this regardless of whether you're really an expert in observability or you're just wondering what this all means. And so to that end, we wanted to, instead of starting off with a bunch of slides and try to explain what observability is and how you do it, we wanted to give you something that's maybe a little bit more visual. We wanted to use a sample application and then walk you through issues that happen in that sample application and how observability can help you as a developer or somebody in charge of a production application enjoy your time and not be woken up so much in the middle of the night and not have to spend days trying to figure out what happened. So that everyone can understand what's going on in this sample application, just wanted to start off by explaining the architecture. So all of the applications are Spring Boot applications, Spring Boot 3 applications, and the application's purpose is a T-service. So there is a T-service application. This is the application that end users would be interacting with. And this T-service will call another Spring Boot 3 application, the water service, that has its own database. And in addition, it'll be calling a tea leaf service that has its own database. And so this is what the architecture is supposed to look like for this application, and we'll be able to confirm later using observability whether that's actually the architecture in production.
Okay, so time for the demo. So for the sake of this demo, what we did is we stopped for a second writing libraries, and we decided to write production apps. And this is the best we can do with the UI. I mean, we think that this is like thank you, like 2023 stack. It's responsive because when you click on the box, can you do it? It reacts. It's responsive.
Reactive design. This is
reactive design, responsive Kubernetes. This is everything we have here. Is like the best of the best. So what do we have here, Tommy?
So this is in the architecture that I showed before, this is the T-service application that we're interacting with. And so you can select which kind of tea leaf you want. And so I like sencha, and I'm really thirsty up here, so I'm going to do a large on the water, 300 milliliters, steep it, and it gives you all of the details that you need to know about that. Okay. And so that's working. I'm satisfied. Marcin, would you like some tea?
What kind of tea leaf do we have? Oh, English breakfast. Who wants an English breakfast? Okay, good.
All right.
Let's do it. Give me the English breakfast.
What size do you think we need?
So, I mean, we need to share it. So 300 milliliters, everybody gets a milliliter. That's fine. Let's do it.
All right. And I don't know how you brew your tea, but I don't typically do it internal server error.
Hey, wait. I think this is a bug in Firefox. Can you click 5 more times?
Yeah.
Okay, refresh.
Oh, okay, see, it went away. There's no problem.
Okay, click again.
No, are you sure? Oh, okay, well.
So, I mean, we tried to push the problem to somebody else, but most likely it's our fault. So what can we do about it, man?
Well, we are responsible for this, so I guess we're the ones who have to fix it, right? I mean, can we just admire the UI instead?
That's one way of things, but we're going to get fired. Let's maybe look at the metrics.
Yeah, okay, that sounds like a good idea. So we can see we just tried 5 times, refresh the page, that didn't work, which is weird because that usually does. So we can go over here and we can check out the dashboard that we have already made for this T-service application.
You know, because I have a problem with the eyesight. Can you zoom in on things?
Oh, okay, yeah. Is that
yeah, that's too good even. Yeah, that's fine.
Can everyone see? Everyone? So we have this dashboard for the T-service application, and we've got a couple of different panels in this dashboard. So we have one here that's showing the latency, and then we have one here showing the throughput. And you can see on the throughput graph that there are 2 different statuses. So we have errors and successes. And so we can see that there's a more or less constant rate of errors. And we're not using the UI right now, so clearly other users, all of our T-service users, are trying this out, and they're also getting errors. So it's not just my browser. It's not our UI.
Yeah,
because
something
that's
is
perfect.
Problematic here.
Something's problematic. So we need to dig into that. And actually, if you look at this latency graph over here, you'll see in addition to the lines, there are these dots. And if you mouse over these dots, you can see that it says exemplar. So what this exemplar is it's showing a specific request, as opposed to these metrics, which are aggregated across all of the requests that we're getting. So the T-service is getting all of these requests, and among those, we're getting 0.5 requests per second that are errors. But we want to look into the details and figure out exactly why that's happening, so we need to look at a specific request that has an error. So if we had exemplars like this over here, you can just jump over and look at your distributed tracing data and find a specific request that has that error.
So wait a second, do I understand correctly that by having exemplars, you can click this and then see a visualization of the latency of the processing of this request?
Yes.
Okay.
And so that's what we want to do, and we want to do that specifically for one of the requests that was an error, like the error that we had.
So why can't we click it in the throughput scenario?
So that's what we want to do, but we don't have exemplars available there right now, but it is a feature that we're working on. It will be there in the future. And so instead, we're going to have to do this the old-fashioned way and type a few things.
So we will have to SSH to the machine and grab the logs?
No, never.
No.
Never do that.
That's too old school.
That is too old school. We have too beautiful of a UI to be doing those kinds of things.
Okay.
So, old-fashioned way, we're going to search our distributed tracing data. We're going to search the T-service, and we saw in that graph before that it had an outcome, and the outcome was there were successes and there were server errors.
Wait a second, do I understand correctly that due to the fact that we have a Spring Boot app that has actuator on the class path, thus has micrometer there, we have instrumentation, and we have instrumentation of the HTTP-related components that when an error comes, they tag the metrics or spans with the information there was an error.
Yes.
Okay.
And we didn't have to write any of that code ourselves so that we could spend all of our time
on the UI,
that UI.
Of course.
So we didn't have to write any instrumentation. That was provided by the Spring projects that we're using and Micrometer. So we're going to search the, if I can zoom out, there we go. So we're going to search the traces, and so these are all of the recent traces that are in the T service and that have an error. So this is how we can find a specific request. So I'm just going to click on one of them, and now this is a visualization of the tracing data, and it's probably a bit small, but you can see there's a hierarchy here between the services, and so you can see they're nested and they have a parent-child relationship. So you can see that the T service is calling the water service, and see the T service is calling the T leaf service. And you can see exactly how much, oh, if I didn't, technical difficulties. Okay, we're back. So you can see how much time is spent in each service and each part of that service. And so this is very useful if you want to drill down and see how much time is being spent and what services are calling what services and where the errors are happening.
So do I understand correctly that if you zoom in a little bit, we have this water service connection, and to the right we have the bar, so that represents the duration of the connection?
Yes.
Okay.
And you can see visually here, there's an icon that's showing an error. So we knew that this was going to be an error because we searched specifically for the tracing data that had an error in it. But this is showing that the T service had an error, and then you can look down through here and you can see there was no error in the water service, but this T leaf service also has the error icon. So you can see that's where that originated. And we mentioned before that the architecture is supposed to be a certain way. And if I can zoom out again, you can see here a service graph that should match what we were looking at before. So you have the end user calling the T service, and the T service calling the T leaf service, and the T leaf service calling the T leaf database, and the same thing for the water service. So this should match, and we can see exactly based on what's actually happening in production instead of what we intended to design, what we intended to deploy. You can verify based on actual requests from users what is happening in production.
So wait a second, why did we, on the slides, take images of servers instead of screenshotting this? We would have more time to work on the UI.
You're right. But when we made that architecture diagram, we hadn't made these services yet, so we couldn't get this image. We had to deploy these to production, actually get requests, and then we could get this image.
So it's like bracket, bracket, cylinder, right? With the service database thing? Okay,
yes.
I get it.
So if we go back to the trace view.
Yeah, what is the problem? Why did we have the exception?
So we could see that the error is happening in the T leaf service, but we need to dig in. And if you click on one of these, you can get even more metadata about what happened in that specific span, it's called, which is just a unit of work.
Can we zoom?
So if we look here, you can see there's these attributes, and you can see that the error is set to true. But there's a lot of other really useful metadata that we're getting from the different Spring projects. So this is a WebMVC endpoint, I believe. And so we can see the actual URL that was called, HTTP method, outcome, HTTP status, all of these kinds of things you get attached to your tracing data. So this way you can drill down and see for a specific request exactly what happened in that request and where. But so we can see that the error message here is resource not found, and it's trying to search for English breakfast.
So maybe the reason for this exception is that there was no resource.
That is what it is saying, isn't it?
Yeah.
But we should probably dig in a little bit more just to confirm. So you can see the query here. And so you can see that we don't just have the HTTP layer instrumented, we have the JDBC layer also instrumented. And here you can see the actual query that's going to the database is also attached. to the metadata in your tracing data.
So due to the fact that the boot apps are instrumented with micrometer, due to the fact that the JDBC integration is instrumented with micrometer, we can see all of this information bound together, right?
Yes.
Okay.
And without you having to write any of this instrumentation yourself, you can spend all of your time on the UI.
Of course. Wait, this is the result set, right?
Yes. So
why do we have the JDBC row count equals to 0?
So I'm guessing it must have ran that query. So ran this query, and then it went to process the result set, but the result set was empty.
So are you saying that in the UI, we have put a value that is clickable, but is not present in the database?
Yes. In our perfect UI,
okay,
there was an option that we forgot to actually put the data in the database.
Okay, that's not good. But maybe you're wrong. Can we check the logs for this whole trace, for the processing of this whole request? Maybe we'll double check this in the logs.
Yeah, so there is this handy logs for the span button right here. So if you click on this, it opens another window, and now using another component in the Grafana ecosystem called Loki, you can look at logs that are also collected from your application. And because we're inserting the trace ID and span ID into the logs, we can search for all of the logs that match this specific trace ID. So now we've looked at the tracing view, and we can see everything that's happening over here, and then we can actually see the exact logs that correspond to that trace from that one specific, say, user.
So I can put them in a chronological order instead of me SSHing to every single machine, looking at the logs, grepping for the trace ID, copying it somehow, and gluing it together. I have it everything in the single place.
Exactly.
It's fantastic.
So we can confirm from the logs exactly what happened, and you can see the resource not found, which was also in the trace data. So we could basically piece together what happened just from looking at the trace data, but in case you can't, or in case you have some special information that you want to see in your logs, it's easy to jump from the traces to the logs because that is correlated.
So wait a second. So what we managed to do so far is we had metrics. From metrics, we've managed to jump to traces. From traces, we've managed to jump to logs. Now, there is a chance that, for example, one of the users would tell us about this bug. They would file an issue and copy the log that they have seen, for example, containing the trace ID. Could we then, if let us assume for the moment that we are in this particular situation, could we, from the trace view, jump to the corresponding metrics?
Yes, actually. So there's this link here. And
can you zoom?
If you click on the link, you can look at the metrics, the throughput or the latency for a specific span. And so if I click on that, it's going to open up another window, and it's going to look for the metrics that have the same matching tags to that span that you clicked on. So for instance, this might be useful if you found, so we were looking at the metrics before, and we saw that there's a consistent rate of errors. So it's not just a one-off thing, it's not just one thing happening. But how do we know that the trace that we found actually is the same issue that everything's happened? Maybe there are multiple issues, and maybe the one trace that we clicked on, we were just unlucky, and that was something that nobody else is having. So you can do this now, where you jump to the metrics and see how many of those exact matching tags in the metrics correspond to that trace. So it's not just one trace that has that. We can see here that over time, there's multiple matching. The throughput is non-zero, right? So we're getting requests that match the same span.
Sure. Okay, how can we fix this?
Well, I think we've got to put that English breakfast in the database. So I just happen to have a request ready to do that.
This is amazing. How did you have it prepared, man? Like, as if you had known before that there's a problem.
I mean, there's no way I could have known, but really conveniently.
So can you zoom?
I cannot.
Oh, you cannot.
Oh, there we go.
There you go. So what we managed to do right now is send a request to the API to insert the missing English breakfast tea leaf, right? Or type
yes.
of tea, yeah.
And so that was successful.
So if we go to the metrics, now we should see things getting better, right?
Yeah, let's go back to the dashboard. So the T-API dashboard that we had before. So it's going to take a little bit of time because...
So let me try to summarize what we did until now. So we clicked our fabulous UI, which resulted in a fabulous exception. Then we went to the metrics and confirmed that the problem is more generic. It's not only our browser. Then from the metrics, we managed to go to traces that we could, let's say, analyze to verify what is the potential cause of the exception. So we managed to drill down that the exception is in the database, comes from the database because we're missing an entry. So we added the entry, and now the problem is gone, right? Because we have...
Yep, so now we can see the throughput. There are 0 server errors. So
okay,
all
so I think
successful.
that can conclude the presentation. We're done, right? Or like, is there anything else you want to tell me about?
No, I think it's probably, it's looking pretty good.
Wait a second, like, can you explain me the heat map? Like, why is it moving upwards? What is going on here? So I understand that previously, so with the heat map, we have buckets of latency, and so they're more or less around 20 to 90 milliseconds, and now we have around 300?
That is what it looks like, yeah.
I mean, I think the heat map is broken. Like, if we look at the latency over here, no. Either Grafana is broken, or we have introduced latency in the meantime.
Well, I would never do that.
Okay, so that's unfortunate because we already wanted to, end this. But like, if we never introduce any bugs, we're going to get fired. So this is why bugs equals work. So let's now figure out how we can fix this. So you mentioned something about the exemplars, right? So we have those traces corresponding to the given metric in time, so to say. So could we do this like this, that we would take a trace for analysis from before the latency got introduced and compare it to the one that happened after?
That's a good idea. Let's zoom out a little bit. So this is from
before, right?
Before. Yeah. And then let's take one from after. We'll copy the trace ID.
So we can split the view, right?
Split the view here.
Okay.
Put in that one. And so now we've got a side-by-side comparison of a trace from before when the latency was low and trace from after when the latency is higher.
So let's now check this out. So what we have here is the 74 milliseconds case. Okay, so that's the good one, so to say. Now here we have 226. So I can see that the connection has increased in time. Why is it so? Like, it means that there's a problem with the database?
It looks like that. The water service connection.
Water service. So, but maybe again, maybe we're unlucky and we have just clicked one trace that is related to this particular problem. Maybe there are other problems. So if we have a hunch that the problem lays with the database, what we could do is to try to analyze metrics from the water service. And we'll start with looking at the GVM stuff, then Tomcat, etc. And then we'll try to drill it down to the database metrics to confirm that. What do you think?
Sounds like a good plan.
Okay.
So we'll go over to this pre-built dashboard. And you said it was the water service?
Yeah, the water service, I guess. Okay, so can you zoom a little bit? So the basic settings, like there are no spikes or anything. Situation seems kind of normal. I don't see anything out of the ordinary, so let's just collapse this. JVM looks ordinary. Nothing special is going on. GC, every now and then, normal stuff. HTTP server, throughput is the same. We see the increase in latency, fair enough, but that doesn't mean anything. Like if it's the database, it's obvious that the HTTP side will be problematic. So let's ignore Tomcat. Hikari, so the database. What do we have here? Can you show the connection latency? Oh, we see a spike. Okay, so we do have a spike, which means that we have confirmed that in this set of apps, or in all the instances that we have seen and introduced latency, right?
Yeah.
So what we could do is file a ticket to the database team saying, hey, there's a problem. And we could introduce caching, I guess, right? So we would create a new instance, because you mentioned that we are using Eureka, so we would create a new instance that has caching. Then we would tell all the clients that the other instance is getting deactivated. We would wait for it to deregister from Eureka, and then we would have the problem gone. So the only thing that I think we could have done before is to see this latency problem not by looking at the graph, because I prefer not to just sit down on a chair and look at the screen. I would prefer to be notified about the problem, right?
Yeah, I want to sit and stare at our UI, not at some dashboard.
The beauty of the UI, and we should put it in Louvre, the museum. Anyways, so we could create an alert that, given this metric, if it goes like beyond a certain point, then we should get a notification, right?
Yeah, and if we did that, then we would have known without having to just happen to be looking at the dashboard at that time.
Okay, so I think that's it. We've managed to fix the bug. We've managed to fix the latency. Do you want to summarize this part?
Yeah, so we started off with trying out the UI. We ran into an issue, which again, if we had alerts, we would have known about that without us having to actually try out the UI ourselves. But we found that we were getting an error when trying to steep English breakfast tea. And then we confirmed with the metrics that it wasn't just us getting that, but that this was happening across our system. And then we drilled down into the tracing data by finding traces that corresponded to that same error that we were seeing. And then we found the root cause by looking at where the error was originating in the trace, which service. We narrowed it down to we narrowed it down to the tea leaf service. And in the tea leaf service, it was calling the database and not getting any results back. And so we inserted that in, that fixed that, but then we noticed that the latency was high. And we then again went and narrowed that down, and we saw that that was high because of the water service, and it was the water service's call to the database that was slow. And we came up with a plan. We could add some caching, because we don't need to call that every time, and that would solve the latency problem.
Fantastic. So that concludes the demo. Let's now talk a little bit about the theory behind the whole thing. So how does it actually all work? So let's start with metrics. So as we mentioned before, we have Spring Boot apps, the actuators on the class path. So we have micrometer on the class path. And we have been using both the direct micrometer API for creation of different types of metrics like timers, counters, gauges. But also we are using the new micrometer observation API to instrument once and has multiple benefits out of it, but we're going to talk about that later. So how do things work with metrics? So since we have micrometer on the class path, each of the apps are registering their own metrics. Now, what we were using in this demo is we had Prometheus. So each of those apps has a dedicated Prometheus endpoint where, when asked for, it can, let's say, print in a dedicated format the metrics that it got. And then the metrics store, once it polls for the data, it gathers the data, aggregates them, and then you can visualize them. Here you can see an example of Tanzu Observability by Wavefront, but you can use whatever tool you want.
So we were using Prometheus, and you showed Tanzu Observability. Does that mean that those are the only two options, or?
No, so if you go to the micrometer page, you'll see that we are like SLF4j, but for metrics. So you have one abstraction, you don't change your instrumentation code, and you can have different backends. Recently, we have rebranded that slogan because we are more about observability in general. So we are like SLF4j, but for observability. So we don't care about the backend. Backend is a configuration problem. Your instrumentation code will not change if you change the backend. So now let's talk about log correlation. So the fact that we were able to see the trace identifier in the logs and correlate the logs. I'm mentioning here Spring Cloud Sleuth. Who has been using Spring Cloud Sleuth? Okay. Who is sad that Spring Cloud Sleuth is feature complete? Oh. So what we've managed to do is we made it feature complete, and from that we have created micrometer tracing. Why did we do it? So essentially it's a copy of Spring Cloud Sleuth with certain bugs fixed. But of course, we backported them to Sloof. Spring Cloud Sloof required you to use Spring Cloud and Spring. Micrometer tracing does not. It's Spring agnostic. So how it works is that, let's say we have those 4 services, a request comes in, there was no tracing context, so an identifier was generated, so let's say it's 1 to 3. So the thing is that whenever the service logs, if you don't properly see the text, doesn't matter, it's just a log statement. The important thing is that the identifier gets attached. Now, for one service, that's kind of easy, so to say, but what needs to happen is that when we send a request to service 2, this context, the distributed tracing context, needs to be propagated, which means that this identifier needs to be propagated over the wire so that the service 2 is able to actually put it in the logs as well. And the same thing for service 3 and service 4. That means that for the time of the processing of the business requests within those 4 services, you always get the same trace ID. So what happens then? Depending on your configuration, you can store it to the drive or push it to some place or to the system out. Whatever happens, at the end of the day, the logs need to be sent to the log store, and then they are parsed, cut into pieces, and then you can search for them. Like, give me all the logs for the given trace identifier, and then you can put them in a chronological order, and no longer do you have to SSH to any machines and copy all the logs and do all sorts of stuff like that, which of course none of us has ever done, never. Now, for that to work, we need to have distributed tracing, which means that we have a tracing context that gets propagated. But we also need to have, what we want to achieve is to have latency visualization. How does it work? Let's look into this 4 services, let's say, communication. So looking at this, we can say that what we would like to observe, measure somehow, for sure would be this part. So how much time it takes from service 1 to call service 2. Maybe this part. So for example, you have like a very specific piece of code inside service 2 that you want to analyze. So that would be a different observation. And then the same thing for communicating from service 2 to service 3 and service 4. So that means is that you need some sort of a framework like Spring Cloud Sloof or micrometer tracing that handles life cycle of spans. So it will know how to create a span, how to push it over the wire, and how to get it from the wire and continue it. So everywhere here you have a framework, and since you're using Spring, everything happens out of the box. Behind the scenes, you don't have to configure anything for that to happen. So what happens then is that not only do we have to propagate trace ID, but also span ID. Actually, the same thing happens when you're doing log correlation, but I wanted to simplify the example. So here you have the span ID, and now the difference between trace and a span is that all the spans form a tree-like structure, a hierarchy, and they all share the same trace identifier. So if you go over the wire, you have the same trace ID, but a new span ID, because this is a child span. So 2, 3, 4 is a child of 1, 2, 3, 3, 4, 5 is the child of 2, 3, 4, and 4, 5, 6 is also the child of 2, 3, 4, right? So what a span has is apparently a parent ID, start time, stop time, the duration thus, and metadata. So do you remember when Tommy was showing the JDBC result, count, whatever? This is the metadata, these are tags. So once the span is stopped, what needs to be done is the spans need to be sent to a span store. And then you can visualize them. So how it looks like, to the top you have typically the production dependency graph. So from production it tells you how your communication looks like. You have the whole trace, meaning this is the time required to process the whole thing. And you have a single span, which means this particular operation took that much time to complete. Okay, so what options are out there? So there are certain tracing standards. We have OpenZipkin, OpenTracing, OpenCensus, OpenTelemetry. Tommy, what do you think that they have in common?
I think that they're all very open.
They are very open, which is a lie because open tracing and open sensors are closed. They're gone. They should be renamed to closed tracing, closed sensors, because they got deprecated and you should not be using them, which is kind of sad to quite a few customers who have been using their API, had their customizations, and now they're all gone. Now you should be using either OpenZipkin or OpenTelemetry, because OpenTelemetry has devoured open tracing and open sensors. Now this is the new thing. So let's talk about OpenZipkin. It's a mature production-tested project ecosystem that has a multi-language support. So the latency visualization tool has around 16,000 stars on GitHub, and first release was there in May 2016, which is the open source release, because primarily Zipkin comes from Twitter, so it's older than that. Brave has around 2,300 stars. What is Brave? It's a tracer library. What is a tracer library? It's a library that handles the lifecycle of a span. It knows how to start a span, stop a span, annotate it, etc. So it's been first released in April 2013, which is 10 years ago, right? And it supports quite a few languages. So Brave takes care only of tracing, right? Now, OTel, not to mix with OT, which is open tracing, OTel, OpenTelemetry, new multi-language and CNCF oriented. By the way, Spring Cloud Sleuth is also CNCF in the landscape. Don't ask me why. OpenTelemetry Java has around 1,500 stars on GitHub. First release, it's a milestone release, happened in November 2019. The spec has 3,200 stars, and the first release was in June 2019. So first GA releases were about 2 to 3 years ago. And now let's pause here for a second, because for us, GA means no breaking changes, right? So if you do 1.0, then if you break, then you do 2.0. That's quite not the same understanding as in the auto world, because over there you have GA alpha things. I mean, they are in central, an alpha jar, which is describing the semantic convention. So all the names of all the metrics, all the spans, can be changed at any point in time in a backward incompatible way, which we know will happen with HTTP. I don't know when, but sooner than later. So if you have any dashboards, you've been building them for years, all of them gone. And you'll have to write a script to migrate to the new thing. So another thing that OTel does, except for breaking compatibility, is doing the 3 types of problem analysis. So they want to solve the problem of logs, tracing, and metrics, right? For logs, they don't have a separate API. They have a separate API for tracing and metrics. So this is the main difference also with Zipkin, because Zipkin only takes care of tracing. Let's park that thing with logs, tracing, and metrics, because this is something that in Micrometer world we want to address in a different way. So it supports also different languages. So what latency visualization tools are out there? There's a lot of them. We're just mentioning a few. So here we have the Tanzu Observability by Wavefront. There's the Zipkin one. There's Jaeger. It was shown even today at 9 a.m. at the presentation. And during the demo, you've seen Grafana Tempo. For metrics, again, Tanzu Observability by Wavefront. You've seen Grafana today. And for logs, who has heard of Elk Stack? Yeah, quite a few people. So Elasticsearch Logs/Kibana, a very frequently used stack for logs. Today we've shown you the Grafana low-key tool as well. Okay, now let's talk about Micrometer Observation API. Who has been using this API? Wow, there are quite a few people. That's interesting. So we believe that you should instrument once and get multiple benefits out of it. Because you have multiple APIs to do tracing, metrics, etc. If you have one block of code, you have to instrument it multiple times with different API. We believe that this is not the way to go. We believe you should do it once. So you have an example here. Hopefully you can see it. A very simple example. You have an observation registry. Your chicken can configure in different ways. You have a context, which is a mutable map, so to say. In essence, if there is a method that you want to observe, called do some work here, You would create an observation, give it a name, for example, my operation, call observe, and that's it. This is the whole instrumentation code. And when you do that, what can happen is you're going to have metrics, traces, and logs, and whatever you want. How does it work? In Micrometer, we have the notion of a handler. A handler reacts to events like start an observation, stop an observation, there was an error with an observation, etc. So we come, like Micrometer gives you such handlers like the metrics handler that uses the Micrometer timer when it starts, and Micrometer timer is getting stopped when the observation stops. And then you can ship the metrics wherever you want. Micrometer tracing gives you tracing handlers that can start spans, stop spans. You can use here Brave or OpenTelemetry tracer to create those spans. You can use not the Micrometer API to create metrics. You can use the OpenTelemetry metrics API. And that's fine. So whatever you pick, this is an implementational, configurational detail, because you separated this from the instrumentation code. In your instrumentation code, metrics and traces should not leak at all. And the same thing for logs, like you can log whatever you want. We are not providing a custom logging solution because we don't know what you want to log, so you can provide your own. And we're good with time here, so if you have any questions, and we have the app as well for the questions.
We have a couple questions on the app.
We have the question. Okay, so maybe we'll take the questions from the app first, and then if you have any questions from the audience, we're going to take those.
So first question that came in was, would you recommend this kind of setup with Grafana, et cetera, for a monolithic application? And I think the answer is yes, you can certainly use tracing and metrics and get benefit out of that even in a monolithic application. I suppose the difference there is that if you want to debug something or see where something is called from, if it's a monolithic application, it's much easier to do that just in your own IDE because it's not across multiple services. But you can certainly still get benefit out of this because you don't want to, it's not as easy to debug even a monolithic application in production, right? So you want to know what's actually happening based on real user requests in the wild, so to speak.
And if you're using a project like the Moduleaf project that Oliver is running, it has an inbuilt observability support that creates separate spans when you cross the boundaries, which means that normally, like in the microservice architecture, you would be making network hops. Here you're not making network hops, and you still see spans, which is great. So if you have a monolithic application, and it's a Spring Boot free app, the only thing you should be doing is adding manually observations wherever you think it makes sense to add them in the trace view.
And this is also somewhere where we offer annotation support. So we have an @observed annotation that you can use on places where you want to have that separation of this is a separate operation that you want to have timing data for metrics and tracing and any other handler that you might configure. So I think it's definitely viable to use this in a monolithic application. And as we showed in the example, even in a microservice kind of world, we had the HTTP instrumentation and the JDBC instrumentation. So there's still a breakdown of timing within an app, within one service.
I would not only say this is viable, you should do it. You definitely should do it. Any more questions?
We have a lot of questions now.
So let's try to answer them. I mean, time is up, but we can, let's say, talk for one more minute.
I think that clock's fast.
Oh, yeah, you're right.
So the next question that we had was, will the trace ID be generated for all Spring applications, for example, Spring integration or Spring batch?
So the very idea of, one of the key themes for Spring Boot Free was the observability thing. So we created Micrometer observation, Micrometer tracing, and we discussed this with many projects, Spring projects that are actually already being instrumented with Micrometer observation. We automatically generate documentation given the observations that they have, so you can go to their docs and check exactly what kind of observations they do. So the answer is yes. We haven't actually instrumented all the projects, but we are all working on that.
Next question.
Can you let's say it in a different way? Can we remove OpenTelemetry if we migrate our Spring microservice to Spring Boot Free and make use of Micrometer. I don't really understand like fully the question, because if you're using micrometer observation with micrometer tracing, one of the tracers you can use is OpenTelemetry. If you're saying we want to not use the agent, then the answer is yes, you can consider that. Because there might be a case that we don't instrument a given library, but then just file an issue and going to fix it, because there's more and more external libraries that are using micrometer observation. But yeah, you can consider doing that.
What about tracing the case when service A is calling service B, but not in a direct way over HTTP, but rather over a message broker?
Of course, we're instrumenting Spring Rabbit, Spring Kafka. We are also actively working, as we speak, with the RabbitMQ project to have native observability instrumentation in RabbitMQ. So it's already working.
Answered that one. How did you solve the latency in T-Service? So we didn't actually show solving the latency problem in T-Service. If we had more time, we would show, but it's really pretty simple to implement the caching with the Spring cache annotation, enable caching, and you just add the annotation to the data repository.
You do cacheable, provide the name, and you're done.
So we didn't show that, but
and the latency got introduced. I don't know if you've seen how Tommy was so fast that he switched the screens and typed in make chaos. So in the make file, what we do, so the thing is that one of the apps is not communicating with a MySQL database directly, but via a Toxi proxy. So what we did, we introduced latency in the Toxi proxy. This is why. It was exactly 50 milliseconds for the connection, 50 milliseconds for the results, that does 100 milliseconds of latency. I think we're out of time, right?
Yes.
So let's maybe conclude for now, and we're gonna, let's say, go outside and answer any of the questions that you have. Thank you so much.